Now, our motto determine tension in each string. So, how can we determine? First of all, we focus on that question, that is M, and here 2M. There are two strings here. This one is T1, then here T2 develop. Okay, tension here T1, so here T2. Clear or not? So, first of all, how can do it? Make free body diagram of each block. Mg downward, here Mg downward. Clear or not? Very simple. That is indirect contact force. And now 2Mg, this is 2Mg downward. Tension develop T1, here tension develop T1, here tension develop T2, here tension develop T2. Clear or not? After that, this force, this surface also apply. Okay, two forces. First one, here normal force N1, frictional force F1, here frictional force F2, and here normal force N2. Clear or not? Okay. If surface is rough, then rough surface apply two forces. First one frictional force, second one normal force. Normal force always perpendicular to the surface. That's why I represent like here into here N1. Now, first of all check this whole system motion allow or not. Okay, the whole system are moving or not. So how can check? You can consider, first of all, you can consider at t this equal to 0 pe just motion start. Just motion start means at t this equal to 0. What about a? Just t this equal to 0. A this equal to 0. Okay, let us consider if a this equal to 0 means motion, just motion starting. Okay, just motion at t this equal to 0. T this equal to 0 means suppose that a this equal to 0. This whole block. Okay, a this equal to 0 means T1. What about T1? That is 2mg. T1 is 2mg. Now, look here. Apply force on that string, that is 2mg in upward direction. Maximum frictional force allowed by these two surfaces, that is F1 is written as mu into mg, F2 also mu into mg, and what about mu? It is less than 1. So if you let consider mu this equal to suppose that 0.9. So maximum frictional force in opposite direction, that is F1 plus F2, how much? This one is, if you consider 0.9, so 0.9 into mg, and this one is also 0.9 into mg. If both are adding, then we got 1.8 mg. That is a frictional force in opposite direction. And what about applied force? That is 2 mg. Applied force is greater than frictional force, maximum frictional force. Okay, means applied force F is greater than Fs max. It means motion allow. It means A is not equal to 0. Clear or not? So first of all check both block moving or not. So how can check? If you consider A this equal to 0, if you consider A this equal to 0, at the, you can say that A this equal, if you suppose that A this equal to 0, just motion started, it means A this equal to 0. That time we got applied force is greater than, we have assumed then A this equal to 0, then we got T1 is equal to 2 mg, means T1 apply here, T1 that is 2 mg applied force, maximum frictional force this one plus this one mu mg, here mu mg, that is 2 mu mg. Mu is less than 1, means if we consider 0.9, suppose that, so 0.9 plus 0.9, that is 1.8. So 2 mg is greater than 1.8 mg. Okay, it means that is static frictional force like that one and applied force like that one. So applied force is greater than static frictional force, then you can say that motion allow. I have already discussed, if applied force is greater than frictional force, maximum static frictional force or limiting force, then motion is allowed, means A is not zero. If A is not zero, means whole block are moving in which direction? In this direction. Clear or not? Whole block moving corresponding to that direction. Clear or not? Clear? So now next target is how can determine A. Our next target is what about A. Clear? So first of all, clear or not? This motion is allowed or not? This motion is allowed. So we have focus on this system is going on downward, this one is going on here and this one is going on here. Okay, 2 mg minus T1, this is equal to 2m into A, equation number 1. T1 minus T2 minus F2, F2 is mu into mg, this is equal to m into A, that is equation number 2. Now here T2 minus mu mg, it is written as mass into acceleration, that is equation number 3. If these three equations are adding, then we got 2 mg minus 2 mu mg, this is equal to 4 m into A. Okay, so what about A? A is written as g into 1 minus mu divided by 2, that is acceleration of each block. Now next target is determine T1, T2. Okay, so how can we determine? Simply, if this value put here. Okay, so if you put here, what about T1? T1 is 2 mg T1 is equal to 2 mg minus 2 ma minus 2 ma. 2 ma is written as m into g 1 minus mu. Okay, now mg is common, so 2 minus 1 plus mu. Okay, 2 mg minus 2 ma. T1 is written as 2 mg minus 2m. What about A? A is written as g 1 minus mu divided by 2. So 2 mg minus mg 1 minus mu. So what about this value? If m into g common, then we got 2 minus 1 plus mu. So mg into 1 plus mu. Okay, that is T1. Now put here T2, that is mu mg ma g into 1 minus mu divided by 2. If mg is common, two mu plus 1 minus mu divided by 2. Now that is mg by 2 into mu plus 1.